Sorry for the delay. I'm just trying to get an email out. Hopefully everyone's doing okay today. Let me fix my windows. I have a new microphone. It may not be perfect, but it's doing the best that I can at making this the easiest on your eyes and ears as possible. Okay, so here's what's going on right now. We'll work on Lab 10 together on Thursday. The topics for today, we're starting to work with arrays. So this is sort of a big step forward for us in the semester where we get to solve a lot more interesting problems, I think. So today we'll just sort of go over the basic concepts, and on Thursday we'll work through a lab to practice our skills around those concepts. So we'll talk about what arrays are, then we'll look at the techniques for printing arrays, which once you learn to do that, then you've got a lot of the skills to process the data in arrays down, and then we'll work on how do you manipulate the data in an array. So I'm going to fire up a Go program to look at this stuff. Okay, so just to get us started, the main difference between an array and just like an irregular variable is that an array holds many things. So holds many things in one place. That's all an array is. So the nice thing about this is that it's very easy to scale up an array of variables as opposed to single variables. So if I wanted, let's just do it sort of before we had arrays, how would we have 10 integers in a program? Well, we do something like this. I'm actually going to go ahead and do this. You don't need to, but just to show you how much better arrays can be. Right, so that's up to this point in the semester. If we need 10 integers, we're going to have 10 separate integer variables. But with arrays, all we have to do is specify the size of the array, and that gives us as many values as we need. So I can very easily scale that up to 100 or 1,000 or 10,000 or even 100,000 or 1,000,000 if I wanted to. And I would have to do no more work to get started other than change the size of the array. You'll notice the square brackets. That's the term that I'll use to describe these. The square brackets, you'll see those a lot when you get arrays. So that's the big difference. And I'm going to get rid of all these separate ones because they're just a mess. So I have my list of numbers. That's the name of my array variable, and it has 10 integers in it. So just the basics, you can actually you can use the array, and it will tell you how many elements it has inside of it. So I can say my list has %d integers in it. And then the Go language has a function called len for length. So you can pass in the length you can pass in your array to get its length. So this program, when I run it, it's going to say my list has 10 integers in it because I create it to have 10 integers in it. Oh yeah, now it's not going to like my original integer variable, so let me get rid of that. Alright, so there's my list, has 10 integers in it. There's a quick way to print out the entire array's contents at once in the Go language. So hopefully you would be able to guess this right, but if you just declare an array variable and you don't specify any values for it, it will be zeros. So just like an individual integer variable will be 0 to start, an array of 10 integers will be 10 zeros to start. And you can print out the whole array at once like this. You can use the %v to print out the entire contents of the array. So let's see what that looks like. So there's 10 numbers. I could count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my list of 10 zeros, which is what the Go language defaults to when you create any variable, single variables or arrays. It will put it in its 0 state. You can have strings. So I could have like an array, let's say this time an array of 3 strings, which to start, I'm just going to steal these 2 lines of code. So my list has, I'll change the words, I have this many messages, and then I'll use the length of that array, my messages, which is 3. For a string array, the 0 state is empty strings, so sort of imagine that as empty quotes. My messages, and then I'll switch this out to be this array. And I'll print those out. So I have 3 messages, and you can't really see it, but there's 3 nothings in there, basically. But because empty strings print as nothing, that's what you get for a 0 state string array. You can have arrays of floats. I'll do 5 this time. So you can do arrays of anything, and they're really nice because they allow you to scale up to larger and larger amounts of data with less and less coding work. So I'm going to go ahead and copy those 2 lines, do the same thing. I have this many scores. So notice I use the length, the len function on a different array, and then I'll print out my scores, which will show all of the scores in their 0 state to start. And while I'm at it, my answers, let's just say 7 just for the heck of it. You can also make arrays of booleans. This will be less common in our class, but you certainly can do it. Make arrays of booleans. I have this many answers, and my answers, and we'll see what the 0 state for my answers is. It should be falses. And then we'll look at all those when they print out. Okay, so there's my 10 integers, my 3 messages, which in their 0 state is empty strings, so they don't show on the screen. Here's my 5 scores. And because I haven't done any formatted printing, they're just going to show as zeros, even though I know they're floats. And then here's my 7 booleans, which are 0 stated to false in the Go language. So that's really just to show you that you can create arrays of any kind of data, and what you get is a whole collection of that kind of data. Okay, so that's step 1, is just sort of how do you work with. I should have put these in a different order. Let me put these in a different order. Let's do storing data in arrays in a second. Okay, so there's a whole bunch of different ones. So now I'm going to go up here. I'm just going to use these kinds of markers to separate out my sections. So it's easier for you to see on the screen where the sections begin and end. And at the end of every section, I'm just going to put a blank line in there so that there's an extra space between all the sections. Okay, so let me grab this bit. Okay, so here's my array section. Okay, so now we know how to create an array in its 0 state. We know how to get the number of elements that are in it with the length function, and we've seen how can we print out the entire array's contents at once if we want to do that. We notice that there's no really formatting control for floats when I do that. It just prints out in whatever its default setting is. Okay, so now let's play around with this numbers list array. So this thing, if we were to look at it, if we were to print, it would print like this: 2, 3, 4, 5, 6, 7, 8, 9, 10. This is how Go prints it on the screen. And arrays would not be useful if you couldn't access the individual values inside of it. So you're not always just interested in, well, what are all of them? Sometimes I want to go change one of them. I might want to change the one in the middle or the one on the end, something like that. So the next step is, how do you actually go inside of an array and get just one of the things that's in it? So the way you do that is with what we call indexes or index values, or indices if you want to be fancy. I just say indexes. So every individual value has an index number associated with it. This is going to take some getting used to. It's a very computer sciencey kind of thing to do. But arrays in most computer languages, when you are counting the individual elements of the array, they start from 0. So we call this zero-based indexing. So the index of the first value is 0. And then I'm going to show you how to use that. So the index of the second value is 1, the third 2, 3, 4, 5, 6, 7, 8, 9. Those are the indexes. So the 0 index is the first value, the 1 index is the second value. So you can kind of see how that works. If we start counting from 0, then what we would normally say is the 10th value is actually index 9. But we can use that. So let's use that. So I'm going to go into my list of numbers. With the square brackets, you can supply an index value, and this gives you access to that one value in the array. So this is the one value in that array, my list of numbers at index 0, which would be this value right here. This one. So I'm going to change it. I'm just going to make it 10. And then I'm going to print out the whole thing again, mostly to prove to you that the first value is now 10, as opposed to 0. Okay, so here's the new list, and there is the value at index 0 having been changed to 10. I'm going to do the same thing. I'm going to go to index 9, which happens to be the index of the last value. Notice, by the way, that the index of the last value is 1 less than the size of the array. So an array of 10, its first element is 0 and its last element is 9. But let's change that. I'll make it 99. And then I will print out the list again to show that the first one is 10 and now the last one I've changed to be 99. So I've written the value 99 into the array at that index. So here's this line where I've now changed the last one, the value at index 9, to be 99. Okay, so now let's go hit this string one. So now we've seen that. Now let's go do all of the string one at once. So, and I don't mean at once, but let's populate. So I'm going to go to my messages. The first element is 0. And one thing to note is that the first element of every array is always 0. That's the index of the first element is always 0. So I'll say hello. I'm not going to say that. I'm going to say buy apples, like a shopping list, kind of. I'm going to go to the next one. So index 1 for a computer science person is actually the second element of the array, since the first one's at 0, the second one's at 1. Buy apples, return book to library. This will be my chores list. My message is 2. Get a haircut. I know none of us can do that now. But if you found a way to get a haircut, good for you. For real. Okay, so one thing to note here, though. This array has 3 messages in it, and I have done 3 storing messages into the array. The first element was 0, as always. The last element is 2. And one thing to note here is that the last element of every array is always the length of the array minus 1. And the reason that's true is because we start counting from 0, which means that when we get to the end, we're always 1 short of the sort of actual count of elements in the array. Right? I have 5 fingers, but if I count from 0, 0, 1, 2, 3, 4. So 5 fingers, 0 is the first finger, 4 or 5 less 1. That's the length of my number of fingers that I have. That's the last one. So that's useful to remember because it allows you to always get to the last element of an array if that's something interesting to do. And now I'm going to use I'm going to copy it. Let's just print the whole thing to show that all my messages got in there. So here they are. And I'm going to use this opportunity. This is not very useful. Hopefully everyone agrees that you can't really tell without kind of taking time to read it, like buy apples, return, book to library, get. I mean, where's the different parts? So this %v, it's handy for quick and dirty kinds of just what does the array look like right now, but it's not good for making it look pretty. And the terms that I will use, and you'll see other programmers use this, is pretty printing. So the %v does not do pretty printing. It does default messy printing, just whatever it wants. Pretty printing means making it look nice on the screen. So now we're going to go to the third thing on our list is printing arrays, and I mean printing them so that they look nice, not so that they look like this. Okay, so this one's a little bit scarier. You've seen a counting loop before, so we're going to use a counting loop here. And then I'll sort of explain to you the magic. Notice I'm starting I at 0. Sort of keep that in your head. 0 is an important number here. If you remember, 0 is the first element of every array. So 0 is important because I'm going to do something with an array and I have something that is 0. This part means I intend to count through or cycle through the entire length of my messages array. This part means one at a time. So if I think about this, if I start I at 0 and then I move I over one at a time in my counting loop, the I is going to go 0, 1, 2, 3, 4, 5. And then the condition that stops it is stop when I is no longer less than the length of my messages. So I know the length of my messages is 3, which means that I should stop when it becomes 3, because it would no longer be less than 3, which means that I is going to go 0, 1, 2, and then it'll become 3, but that's the point where it's no longer less than my messages, so the loop has to stop. So why is it useful to have I be 0 and then I be 1 and then I be 2? The reason why that's useful is because I notice that when I am indexing this array, I need something that goes 0, 1, 2 for me, and the I is going to do that. So I can take advantage of that in my loop by using the I to index the array. So by using the I inside of this loop to index my array, the first time the loop repeats itself, it will be my messages at 0, which will say buy apples, and then be followed by a new line. The second time, I will have counted up to 1. It will be my messages at 1, which is return book to library, followed by a new line character. And then I becomes 2, which is get a haircut. And then I becomes 3, and the loop stops. So this counting loop will actually cause every element of my messages to print one at a time. So let's see what that looks like. So here they are right here, each on its own line, which is a lot easier to understand than this %v style, the default unformatted style. Now I can actually sort of see what the messages are. Buy apples, return book to library, get a haircut. I can see that those are separate things. What would be even cooler is to number them. So here's another trick. Now let's leave that at that. I'll come back to I'll come back to the numbering thing here in just a bit. Okay, so using a counting loop. So you'll see in my comment here that I'm calling this pretty printing using a counting loop. So when I say a counting loop, I mean a thing that goes I equals 0, I less than something, I plus plus. And by pretty printing, I mean something that looks nicer than the %v. In this case, my pretty printing was simply putting a new line between each message. Okay, so now let's go try the floats. I'm going to change this one a little bit. So instead of a 0 state float array, I'm actually going to pre-populate my array with values. So what you can do is, instead of using the var my scores 5 float 64, I can use the colon equal style of creating this array. It will still be 5 floats, but I'm going to put the scores in here now. So let's say I got an 88.7 and a 92.5 and a 96.3 and a 99.9 and an 85.1. 1, 2, 3, 4, 5. So this time I have pre-populated the array with data instead of accepting the zeros. I'm going to run that, and let's see what the %v style of printing does this time. Okay, so it did just fine. So I'm pleased with that. I might have 5 scores, but notice here they are. But let's pretty print. And I'm going to use a counting loop again. So for I equals 0, I less than the length of something, and the length of the something in this case is my scores. That's the array I want to print through. And then one at a time. So notice that the counting loop is almost exactly the same. I start at 0, I count up one at a time, but I use the length of my scores because that's the array I want to print this time, not my messages. So I'm printing my scores. Okay. So I'm going to use a percent. I'm going to say 0.2f. Let's get 2 decimal places of precision on them. My scores, and then I'm accessing the individual elements in the array to print them one at a time. And magically, the I from the counting loop gives me my scores at 0, my scores at 1, my scores at 2, my scores at 3, my scores at 4, which would be the last one, 5 length array minus 1. And then when I++ counts up to 5, it's no longer less than the length of my scores, which is 5, and it stops. So let's see what that looks like. All right, so there they all are, to 2 decimal places of precision, and they're all on their own line. But let's do an enhanced pretty print. So let's say, for argument's sake, that these were my scores on the first 5 quizzes in a class, let's say. So I'm going to change the way I print this. And I want to say quiz number %d. So I'm actually going to print out the number associated with the quiz followed by the score associated with the quiz. So the %d filler, I'm going to actually use the I as the quiz number. And then I'll use my scores at I to access the actual score in the array. So I'm using the I for 2 different things here. I'm using it to say, oh, that's quiz number 0 and quiz number 1 and quiz number 2 and so on. And then I'm using the I as the index into the array also. This is a pretty common trick, to use the I for both kind of showing which one it is and also for accessing the actual array. So here's quiz number 0, quiz number 1, quiz number 2, quiz number 3, quiz number 4. That just sort of to make more sense to a human reader. Now, one thing that you'll notice is that most normal humans don't count from 0. But we have no choice but to count from 0 in programming often, because that's the only way to access the first element of an array. So you'll also see programmers do this little trick. And in my pretty printing loop, I know that this I is going to be 0, 1, 2, 3, and 4. If I just put a little +1 on there, I'm actually not affecting the I, I'm just making it appear to be one more than it actually is. And now when I run this, I get human looking output. That was quiz number 1, even though I know that in the program that was actually a quiz at index 0. For a human, that would be quiz number 1, the first quiz that they took. Okay, so let's do, we'll do one more, and I'll show you the one other way to print stuff using this bool section at the bottom. Bools is unfortunate, but that's okay. We'll use bools, and hopefully that'll work out for us. So let's do in true, false, true, false, true, false. Let's make that a size 10er. And we don't have the question part, but let's pretend like this is a little true-false quiz. So we're going to let our user type in their true-false answer. Do I want to do that? No, that's too much work. That's too much work. Let's just pre-populate it and assume that we already knew. Hold on, let me put that back so you have that as a reference. Let's pre-populate this array. So that we can get to the fun stuff faster. So let's just randomly say the first one was true, the second one was true, then there was a false, and then another true, and then a couple of falses. What am I up to? 1, 2, 3, 4, 5, 6, one more, and then a true, which I know by index values is going to be 0, 1, 2, 3, 4, 5, 6. That's the index values, but the total count of them is 1, 2, 3, 4, 5, 6, 7. There's 7 of them. That can be confusing at first. It has 7 bools in it, but when I go to index them or access the individuals, they actually start counting from 0. Okay, so there's my pre-populated. Let's just assume that someone already took the quiz. So now we're going to print out the answers. So I'm going to do another pretty print. And then introduce you to one of the coolest, at least in my opinion, features of the Go language is this thing called a range loop. So this is very different, and this one's hard to get, but a range loop looks like this. So it's not a counting loop. It doesn't have I equals 0, I less than something, I plus plus. It's very different way of going about printing your way through an array in the Go language. So here's how this works. I'm going to range over my answers. My answers is my array. So by ranging over it, what that means is that I'm going to grab each value in turn. So I'll grab the true first, and this true second, and then this false, and then true, and then false, and then false, and then true. I will, as I'm ranging over, I will get one of those answers at a time, and each one in sequence from the beginning of the array all the way to the end of the array. And as I range over the whole array of them, I will call each of those individual ones answer. That's the answer I get as I range over my answers one at a time. The I is the index that goes with that answer. So what you get from a range loop is a pair for every element in it. You get the index of it and the answer of it. So let's try this out. So we'll say the answer to question number, and so we're going to put a question number there, was, and then I guess I'm going to use a, what do I want to use for bool? Maybe a %b here. Percent %t, perhaps? What is let's try it. Yeah. Bools are percent %t. Okay, so the answer to question number whatever was some bool. So that is an integer and a Boolean pair, and that's the pair that I automatically get from the loop as I range over my array. So I will get pairs of I and answers. So the I and the answer pair are handed to me by the range loop. So as I range over my answers, I'm going to get 0 true, 1 true, 2 false, 3 true, 4 false, 5 false, 6 true. So this is another way of going about doing a pretty print, is using a range loop and using the pair, the index value pair that you get. So another way to say this that I try to get people in the habit of, this part over here is singular and this part over here is plural. So the I answer pair is in the singular. It's one index and the answer that goes with that index. And then the plural part is the entire array. That's all of them. The singular part is one of them and its index. The plural part is all of them. So let's see what that looks like. So here they are at the bottom. So answer to question number 0 was true, 1 was true, 2 was false. Anyway, you get the idea. Technically, there are cases where a counting loop is better, and there's cases maybe where a range loop is better. But you pick the loop that works for you, that solves your problem. So if you think to yourself, I really get how range loops work, then use those like crazy in your code. If instead you think, well, I just understand better how a counting loop works, then use those like crazy in your code. Ultimately, your task, your challenge is to solve problems, and you solve problems with the tools that you find best to solve them. How are we on time? I'm pretty good on time. Okay, so that's my introductory stuff. We have a whole lab to work through where we will repeat all of these techniques, and then I've thrown in an extra challenge or two along the way, so we'll experience that on Thursday at 2. So what I'm going to do now is open the floor to questions. So just putting that in chat to prompt you. So that's all of my content. So now I'm happy to entertain your questions. I'd say the floor is open for questions. Whatever, same difference. Okay, so in Lab 12, it's easiest if you make a directory for that stuff and type go test. So your job in lab 12 is to implement all of those functions. So I'll bring it up and show you what I mean by that. So this is the lab12.go code on my screen. So your job is to implement that function. That's it. And once you've implemented it, then you go test. I can go show you on my screen here, but that's pretty much it. Let me so anyway, here's the code. What I have, I'll just show you real quick. Now I have a solution file, but basically I have the fruits file, which all I have to do is this solved is because I have already done it in the past, so don't worry about that. You should have the fruits file in a folder, the test file in a folder, and the lab file in a folder. Your whole job is to write code in lab12.go. You'll know you're on the right track because you'll type go test, and you'll either pass or you'll fail. Now I'm failing, so I have work to do. So I mean, I can give you a start on one, but all I do is just do these functions. So I don't worry about, that's it. So this function, strings of length, as an example, I have a slice of strings and a length. So I have to look through this slice of strings to find strings of this length. That's what I got to do. What I'm going to build is a new slice of strings of all the ones that match. So I'll make a results, which is a slice of string. Then I'm going to range loop over that list. So I'm ignoring the index because I don't need it for this. So for each string I get as a range over list, if the length of that string is the length that I've been told to look for, this length, well then S is one of those that I want to keep. And then when I'm done, I return the results that I made. That's what those are going to look like. I'm going to produce some results. But notice I don't care what the file is. Who cares? I don't need to know what's in it. I don't need to know how long it is. It doesn't matter. I have this list of strings. I have this length, and I just code with that. So, and I know I'm supposed to produce some results. So here's, I'm setting up a place to put my results. I range loop over the given list, pulling out the individual strings. So for each string I get as I range over that list, If the length of that string, there's the S that I got from ranging, if the length of that string is the same as the length that I've been told to look for, then I append that string to my results. That same S, whose length is the length that I want, I append it to my results. That's my loop, and then when I'm done, I return the results that I got. That's it. So don't get distracted by fruits.txt. It has to be there for the test, just like the test has to be there for the test, but you don't code it, you don't care. You just write with what you can see in the function. A list of strings and a length. So they'll all be the same. This next one is a list of strings and a length. So is the next one. So there's some repetition there. So notice that all of them, you don't care. You do something with a list of strings. That takes practice. It feels like a little bit of a leap of faith when you do that. But eventually you'll get used to it. Like, oh, I don't care what the strings are. I don't care where they came from. I don't care who wrote them. All I know is I'm supposed to look through a list for strings of a particular length. If I go test, I might, yeah, I'm getting a little bit further this time. Did I pass any? Let's do a go test dash V. And see if I passed any. Yeah, there's the pass. Oh, that one is just checking to see if the file was there. But here's mine, strings of length, so I passed that one. So these are challenging. This one hopefully will give you a start where you can begin to work through a few of them. But try to put fruits.txt out of your head. Other than the fact that it needs to be in your folder, you don't do anything with it. You don't worry about it. You just worry about lab12.go. And most of your functions should be about that long, probably. Okay, so hopefully that at least gives you some sense of how to do the next few of those. Yeah, why is that not showing? Oh, I know why. I put it in a separate window. Sorry. Yeah, let me move it over. Okay, so I'll need to get rid of this stuff. So here's the one I was just working on here. So all I did, let me cut that out and I'll just rebuild it so you can see it. So that's what it looked like to start. And all I do is solve the problem with what I can see on the screen right there. I don't worry about fruits.txt. I am supposed to generate a return value that's a string slice, so I would usually call that like results. That's the thing I'm going to return, is the results that I get. So this thing right here, that's what this is for. Hopefully you can see that now. You can. Okay. So what's the job? Look through a list. Okay. So that's a loop. I can write a counting loop or a range loop. I like a range loop for this. This is that same, by the way, singular pair. So for each index string, I just called it S. For each index string pair that I get as I range over the given list, that's this guy, what do? Well, I'm looking for strings of that length. So I'll take this string. If the length of that string, S, is the same as strings of length, so strings of length returns a slice containing all strings in a list matching a given length. So I have to go through each string one at a time with this range loop. I look at the length of the string I just pulled. If it matches the given length, that's this guy, then I need to add that to my results. That's a good one. So I take that same S with the length that I want and I append it to my result. That's it. And again, notice I didn't need to know anything about fruits. All I need to do is code with the information I was given. The information I've been given is this list of strings and this length. And then I'm supposed to return is a new list of strings matching some condition. The condition is the strings that match a given length. I don't know what the length is. I don't know where the list came from, but that doesn't matter. And it feels like it matters, but once you get used to it, then you realize, oh, it doesn't matter. I just code with the... Yeah, these are hard. So just sort of, you're wise to retain your humility and ask, because these are not easy problems. These ones when you're getting on to Lab 12, these are challenging. So hopefully that'll, though, help you sort of work through at least a few more. Okay, anybody else have any questions I can answer? Oh, Nate, I forgot to tell you. On that range loop, do you notice that inside of it I'm never using the I? So Go likes you, when you're not using a piece, to ignore it. So you can make it an underscore instead and just says, yeah, I know I'm getting an index, but I don't need it actually, so I'm just going to ignore that piece. I only need the S that I get, not the index. So I just ignore the index with an underscore. Awesome. I'm glad. Okay, I'm going to sign off here. Just remind you that I do get online on Wednesday mornings at 10 to answer anybody's questions, so anybody from any of my classes can drop in. What I'm normally doing while I wait for people to arrive, and I won't sit there forever, but maybe 30 minutes or an hour if no one's around. But anyway, I just work on other things, whatever it is that happens to interest me at the moment, or one of my projects. So you can drop in. For Lab 12, it should be so always with an underscore. No problem. So Wednesday morning I'll be here. Tomorrow morning at 10. So the closer you can arrive at 10, if you have questions, the better, so I don't sign off before you got it asked. And then again on Thursday at 2, we'll work through Lab 10 for us. So thanks for those of you who are being here. I'm not sure if the audio is working any better. I forgot to actually tone down the gain a little bit. But I am wearing an external mic, and maybe that means the sound's coming from further away from my laptop fan. Okay, have a good day, everybody.